there are two different ways of taking a rational tangle and producing a knot out of it. And the reason that there's two different ways is that rational tangles have both kind of a north and south dimension, and they also have an east and a west dimension. Because rational tangles, we are able to rotate in addition to just twisting, right? So, for example, if I start with an empty tangle, like this one right here, and then maybe let's make the rational tangle t squared r, or something like that. So t, remember, takes the north, oops, I got to try to do this with your perspective, takes the northeast and passes it over the southeast. So this one goes over that one and creates a twist. So there's t. Actually, I want to do two twists to get us started. So second twist, again, northeast over southeast. So now I have the tangle that we could call t squared. It has these two sort of positively oriented twists here in the middle. Then I'll rotate, and we decided last time that rotations happen clockwise. So I'll rotate this clockwise. And then I'll do, I don't know, let's say 3 twists. So northeast over southeast once, twice, 3 times. Put this over here. There we go. All right. So this is the tangle we would call t squared r t cubed. And then maybe just for fun, we'll do one more rotation and do one more twist. Because why not? So northeast over southeast. This is t squared r t cubed rt. So it's just some rational tangle. But there's 2 different ways that we can make a knot out of this tangle. The first way is called the numerator closure. And the numerator closure ties together these 2 ends on the top, and it ties together those 2 ends on the bottom. All right, so to form the numerator closure, I would just connect these 2, and I would connect those 2 to one another. And so what I'm going to get is, it could be a knot, or it could be a 2-component link. It's kind of hard to tell from this, but it looks like, if I kind of isotopy this around, it looks like what I got out of that numerator closure is actually, I think this is actually a knot. It's got 3 crossings, and I can kind of, if I look at a diagram, I can trace one strand through the whole diagram. See if I can get this. So if I start from over here, I'm going under, over, under, and then I'm traveling around on this loop, and then I'm going over, under, over, and traveling around on this loop. So I can trace one strand in my diagram through the whole thing. So the numerator closure of that rational tangle ended up with a knot in this example. Of course, the denominator closure is just doing the other thing. Start with an empty tangle. Make whatever tangle you wish. I'll just make another one quickly here. So we'll start maybe with 4 twists. 1, 2, 3, 4. So we have the tangle t to the 4th power. And then I'll rotate. And then maybe I'll twist twice. Once, twice. And then I'll do RT. So one more rotation, one more twist, and then we'll call it done. So here is t to the 4th r t squared RT. The denominator closure is what I would get by joining up the 2 endpoints over here and tying together the 2 endpoints on the side over here. Right? So denominator closure is just connect those 2 and connect those 2. And again, I'm going to get something which I can't really tell if it's a knot or a link. It's got kind of a lot of stuff going on. Let me see if I can get it into a configuration here where we can pin it down like a butterfly on the table and figure out what we actually have. Is this a knot or is it a link? Well, if I trace the diagram going this way, I'm going to go over to here, and then I come back along that one. Okay, it looks like I have a knot here once again, right? But you could conceive that this doesn't necessarily always happen. Even if I just take an empty tangle, just the tangle that has no crossings or rotations or twists or anything and just has 2 parallel uncrossed strands on the top and the bottom. If I were to form the denominator closure and tie these 2 ends together and tie those 2 ends together, I would get just one unknot. But if I form the numerator closure by connecting these ends together, the tops together, and by connecting the bottoms together, now I don't actually have an unknot. What I have is a 2-component unlink, right? So it's a truism of rational tangles that for every rational tangle, one of the closures, either numerator or denominator, is going to give me a knot, and the other one is going to give me a two-component link. And which one we get really just depends on which tangle that we have. And that's another question, just like with braids before. Is there a way for us to predict whether or not we get a knot or whether we get a link when we form either the numerator or denominator closure of a given tangle? That's actually a question I don't know the answer to off the top of my head, but it would be a great sort of research investigation kind of question if you're interested.